comparing distributions of categorical data. So we're going to compare, which typically means we're going to utilize a two-way table. And we want to compare. So for example, here's a very traditional question. Typically, problem 1 on the AP exam will have something that might even just be like this. Compare. A lot of times, compare or describe a distribution is typically the first thing that you will see on an AP exam when you get it for at least the free response parts. So it's our first our part that we want to make sure we understand. How do we compare? And so the question here is that we're compare the distribution of vision amongst or for each gender. So we're going to utilize the information that we had gotten yesterday. I might need your help. So we had, what do we have, female or male on top? We had female on top, or we had vision here, and we had glasses, we had contacts, we had neither, and what was on the top left? I can pull up yesterday's notes, but I guess I can go back real quick.
Was it female and male?
Yeah, I think it was.
Yeah, it was male at the top and then it was female.
Male and then female, like that. Oh no, that was the other problem. Sorry. Female. So this is what I'm asking about right here. Just paste. So I'm just using that just as a reference, and then I'll delete it. So we had female, gender is written right here. We had males, and we had our totals. Row total or total totals. 8, 1, 5, 14, 4, 0, 4, and 8, 12, 1, 9, and 22. So that's just from yesterday. That we had. So we want to compare distributions. So whenever we compare, first information here, if we have to compare, it's important to understand we need to use relative distributions. And here's the reason why. Because are there more males or more females? In this problem?
Females.
There's more females, okay? Let's look at the neither ones, right? There are 5 females that don't wear any contacts or glasses. And there are 4 males. All right? So who's more likely to wear neither? You would think if you look at the raw numbers, the counts, it looks like 5. 5 is greater than 4. But wait a minute. That's 5 of 14, which is less than half, which is about a third. But for the males, it's 4 of the 8, which is half, which is 50%. So who's more likely to wear neither? It's actually the males are more likely to have neither than the females, even though the females have more, but because the females had so many more, there's so many more females within the class. So because of that, when we compare categorical data, we always use relative distributions. Remember, relative distributions means what? It's a fancy word of saying use the what? Percentages. Very good. Now, what, or actually, well, yeah, what are we comparing? What is the variable that we want to compare? Now, it's tricky here, and it is tricky, but if you follow kind of what we did in yesterday's class, there seems to be two options, and you might even throw in even more. But what is the variable? What is the question that we want to break down?
What is the percent of the number of female on the class?
Well, when I say the what I'm referring to is the variable. What is the question that is being asked? So there's two questions here. The what?
The vision.
Yeah, there it goes. It's vision. Because it says the distribution of vision. So that means I want to break down vision. So that means that I want to have like blank glasses, blank contacts, blank neither. That's what's going to tell me. So when I write my answer, I want my answer to have glasses, contacts, neither. I need to make sure I break down the vision. I need to talk about the distribution of vision. Now, this is very similar to yesterday when I just asked you to describe. I asked you one of these when I used the word conditional probability in yesterday's class. And basically, that's what we're going to use. It's basically the same thing. It's basically the same thing, but when we compare it, we're going to do the exact same work. So, who am I doing it for? Correct. I'm doing it for the students, but I'm going to do it for each of the genders, which is males and females. So that means how many sentences am I going to have to write? Two. Yep, that's it. I'm going to write 2 sentences. All right. And we've already kind of done that. So let's do it. Let's start with the males. Let's start with the females. And I'm going to write it here's the first sentence, of the how many females?
8. 8. What's up? You said
Females.
Glasses?
No. How many females are there?
14.
Of the
14, yeah.
14 females. All right. Blank wore glasses. Now notice that I didn't say the word vision, but because I'm breaking down vision, it's okay. If you want to say the distribution of vision and you want to add that to the beginning of your sentence, that's also correct. I just kind of want to show you that we call this, we're kind of inferring, because when I start talking about breaking down glasses, contacts, and neither, I am referring to the variable of vision, and that counts for the credit as well. Wore glasses, blank wore contacts.
Mr. G,
Yeah.
is there handouts?
No.
What? We can't get handouts?
No. It's AP. There's no handouts to do. We're doing these problems live. We're taking the data that we collect.
It's hard
And-
to do it live. It's hard to do it live.
Yeah. It's the main thing here is that it builds. So we've made this so that it just utilizes the day before and it utilizes the day before that. So as long as you've taken your notes and you have it, your handouts are your previous day's notes. So you should have your notes from your previous day readily available.
Alright.
So now, if this question was just remember when we compare, now be careful here on this problem. We don't say 8. We don't want to say 8, 1, and 5. We don't want to do 8, 1, and 5. because those are counts. We want to do percentages. So what number is going to go here? Or how do I find the value that goes there?
Should you do 8 divided by 22 or 14?
Yeah, it's 14. Yeah, we're going to divide by 14. And here,
1 divided.
and here,
5 over 14. 5 over 14.
perfect. Now, so here's a more simpler way of doing it, because you're like, wait a minute, how do I show this in my problem? Well, let's look back on our table over here. We want to divide by 14. Because of the way we're doing it, we want to do it for the females, and then we're going to want to do it for the males. So you can actually do the work directly in here on your table that can help you. So that means we're going to, if we want to divide by 14 on this side, so we're going to take this and we're going to divide it by 14. We're going to divide this by 14, and we're going to divide this by 14. And I can write this information right into my table. All right, that will help me do these problems a little easier. Now, of course, if I wrote it like this, then I just got to make sure that my answers are percentages. So if I wrote it like here, then I can now go over here and making sure that I write it. So what is 8 divided by 14? What is that about? What is 8 divided by 14 about? And we actually got these same numbers yesterday.
So 57.1%.
About 57%. Good enough. 1 divided by 14?
71%.
7.
7%. Yeah, we got 0. Yeah, 7%.
And finally, I mean, we can do the math, right? And we know that's 64% total. So
yeah, that's 36. 7 added 1 is 5 years.
Yeah, so 57 plus 7 is 64, which only leaves 36% left over. Boom, done. For that, am I done with the problem?
No.
No. Of the
Females.
no.
Males.
Okay, but more specifically, of the 8 males, blank wore glasses, blank wore. And if you're asking me, aren't you doing the same thing as describing the conditional distributions of vision among each gender? That was the question yesterday. I know it sounds like such a complicated thing, but yeah, we are. They do the same thing. Wore contacts and blank wore neither. All right. What am I going to divide each of these by? Yep, by 8, by 8, by 8, by 8. And I can do that math in my head. That's nice. I got to make sure that when I do these, they add up to 100%. That's very, very key. If what you do in your work doesn't add up to 100%, something went wrong. Now, if it adds up to 99%, that's usually just a rounding number thing, and you might want to go an extra decimal place, or don't cry over spilled milk idea. Like, it's not too big of a deal. If it's just because when you rounded the numbers, it adds up to 99 or 101%. That's not a big deal if it's correct math still. So, what percent wore glasses?
50%.
Perfect. And then 0%. And finally, how many were neither?
Another 50.
Perfect. They add up to 100%. I know I've done it right. Boom. Follow-up question. And this is basically the main question that our focus for today's lesson is. Is there and we're going to talk about this word a lot in this course, significant. That's a big word. Significant difference for any of the percentage responses for the same vision type. Are any of these significantly different? Yes, no, but yes, and explain. So you always need to explain. So are any of these percentages for the same vision response amongst the females and males significantly different? Of course, they're going to be different. So the question we always have is, what is a significant difference? Okay, we'll answer that throughout this course. Is 48 significantly different than 50%? Is 48% significantly different than 50%? 48% and 50%. Is that a significant difference? No. What about 4% and 2%? I would actually argue yes on that case. Because isn't 4% double? Yeah. Or let's do a better example. 8% and 2%. Is that a significant difference? 8% and 2%. Yeah, that's like 4 times the amount, right? 8% and 2% I'd call significant. Is 50% and 58% significant?
No.
Okay, I hear a no. Does anybody say yes? Yeah. So I hear a no and I hear a yes. And here's the answer to that one. You're both right. We don't, it's kind of like, it could be either. It could be, we probably don't know. And here's the thing, a good thing about statistics. As long as you argue it, and as long as you kind of say, well, the biggest difference is 50 and 58%. And if you state that you feel that is significant, and that's a big difference, you would receive full credit. If you feel that that is not, you receive full credit. Now, there's certain situations. We call this a gray area, all right? This is a gray area. Later on in this course, and I'm talking about towards the end of the course, we will learn how to do a mathematical and calculation that will tell you if it is significantly different. There is a calculation. Right now, we're not doing it. What we're doing right now is what we call it the eyeball test. We're gonna look at it and say, does it? I think it is. I think 50 and 58% are significantly different. So my answer is yes, because I feel that 50 and 58% for that specific response is a big enough difference. I want to make sure that you're understanding, and the whole purpose of statistics oftentimes is we need to have an argument. We need to make sure that we give our evidence. And here's my answer, and this is the reason why. Both answers would be correct. If a student says no, because, and they explain that, and another student says yes, because they explain it, I would look at that and I would say, you know what? I can see that student's argument. They understand. Now, if it was 10% and 90%, and you said, no, I don't feel 10% and 90% is significant, now you're wrong on that one, okay? So there is a way, but how much and where, there's sometimes it gets it, but you gotta know that 10% and 90% are significantly different. If you don't see that those are significantly different, then I have a car that I'd like to sell you, as we say. So in this problem right here, which is the most what is the biggest difference And is that significant? Is that difference significant? Can somebody chime in? What is the biggest difference between one of the responses?
I was gonna say it depends also on the problem. For example,
Uh,
if
oh, yeah, I'm talking on this problem.
oh well, it's mostly per person. Like can you repeat the question actually? Because
Are any of these percentages significantly different? You just have to point out one. They don't have to all be. You can just give me one, or if they're all the same, you would state that as well.
the one with the females, wears the one who wears glasses and the one that wears neither.
Okay, yeah, okay. So yeah, let me clarify. Okay, so and this is a common thing, Alex. This is a common thing, Alexandra, that people will answer in their question. I really want to make sure, like nip it in the bud, make sure we don't. We are not comparing. We are not comparing within our gender of the questions. We are not comparing the vision responses. We're comparing the genders. All right. We found the distributions of vision, but we want to compare gender, which means we want to compare glasses to glasses, apples to apples. We want to compare contacts to contacts. And we want to compare neither to neither. That's the one. So we don't want to say, yeah, because you're almost, if you do it the other way, and here's sometimes that I go to alarm. If you did it the way that you were trying to, this is just part of learning statistics. It's not being right or wrong. It's just learning part of it. Think about it. You're almost always you're gonna get different. The answer will be always yes, because most likely something's gonna be small like a 7%, and something's gonna be large like a 57%. So you kind of say like, well, that answer would, oh, I'm doing it. I need to look across. I need to look between the two sentences. With that said, is there any responses that are significantly different? Yes or no?
Yes.
Yes. The answer is yes. What is it?
The neither.
Correct. So, yes. So, what is the neither? What is the neither? Can you tell me the responses and who they're for?
So for the female, 36% wear neither.
Hold on. You're answering it perfectly. For females, 36% were neither. Okay.
And for males,
I'm gonna put the word while. Or if you put and, that's okay. While for males,
50% wear neither.
50% were neither. Okay. And then so basically, what you're saying is that 36% and 50% are significantly different. Now, this sentence that I wrote right here, I want to point out. I'm going to put this in parentheses like this. That part right there, if you didn't include that part, that's okay. But because it's notes, I want to make sure that we understand why that 30. Because sometimes students will just write two numbers and say yes, and they'll write two numbers, and it's like, well, they're not actually that different. Now, could you have chosen the 7% and the 0% in your answer? Could you have chosen the contacts? Yeah, and I would agree with you. I would say if you said yes, because for females 7% wear contacts, and for males nobody 0% wear contacts, I would agree. I would give you full credit there. What happens if you chose the 57% and 50%?
They're closer, like
Yeah.
close.
Yeah. So if you said yes and you tried to argue for the glasses part, there's in this sense in this situation in this instance I would say no. 50 and 57% are not that drastically different. They're you should always pick the biggest difference basically. That's the answer. You should always just basically, and to argue with it, you only have to argue and show me one. This is a beautiful thing about statistics. If there is something odd, there might be 15 different things, but if there's something odd about one of them, then you can argue that something's odd. But to argue the opposite, you have to actually say no, because you would have to say each one of them. You have to go through all 15 of them to be able to answer that question. Okay. Let me see. We started class. What time did class start? 50. Class was at what time? 95 or 55, correct?
50.
I gotta put a little.
Uh, 50.
I gotta put a calendar. Class ends in 9 minutes or 19 minutes.
So,
All right. So, comparing distributions graphically. So how do we draw this? And the focus here is, how do we look at this? How do we get a visual look at this? Okay, and don't get remember, the chart is not the chart. That's just the data. Okay, this is what we refer to as the data. This is not a graph. So we want to actually graph these. All right. Now, if it was one variable, we'd have two options. We can do a bar graph, or we can do a pie graph. That's if we wanted to describe one variable. So if we wanted to describe one variable, we can use a bar graph or a pie graph, just like you did in your homework. But in this problem, we want to compare two variables, and that's what I mean is that it's categorical. So there are still two options. One is called a side-by-side bar graph, and the other is called a segmented bar graph. Okay, side-by-side bar graph and a segmented bar graph. And I know I'm going to show you this. I'm going to show you both, but here's my word of advice. Always use segmented. It is easier to complete, easier to grade, and yeah, I'm just gonna leave it at those ones. So, you can do a side by side, and I will not, unless I if I just say compare and I don't tell you how to compare. If I don't say to use a segmented bar graph specifically, then you have the option to go side by side, and if you do it correctly, you'll get full credit. I see way more mistakes by students who try to do a side-by-side bar graph. I see far more mistakes. If a student tries to do a side-by-side bar graph, I see more often than not that the student will make a mistake. Okay. And when I grade it, typically I have to go into a lot more detail looking at that side-by-side, because there's a lot more things and intricacies into it that could be wrong. A segmented bar graph is easier to do. It has some basic features that are always the same. which makes it a lot easier to make sure that you've done it right. And when I grade it, it's the primary one. Now, I will never ask you to draw a side-by-side, okay? I might ask you to draw segmented, all right? So that means everybody's responsible for drawing a segmented. If you choose to do a side-by-side, it's okay. But that's just my disclaimer. All right, so with that said, let's look at a side-by-side. Because the reason, so you're like, okay, why are you going to do a side-by-side bar graph? Well, the reason why I'm going to do a side-by-side bar graph is because the segmented bar graph actually is just developed by the side-by-side. So it'll help me explain why the segmented bar graph looks the way it does and makes it easier to read. A segmented bar graph is basically two bar graphs. And of course, it's relative frequencies. Okay. So when you draw it, you're going to have, we're going to do it for the same problem that we had beforehand, right? Vision. We're going to use the same data. Vision here. And over here, we're going to have relative frequency. Okay? And when you do it, sorry, actually I did this one wrong. I did it backwards. You need to create one for males, and you need to create one for females. All right, because we want to break down the distribution. So think of this, and the other problem, we would have wrote students. And if it was a single one, when we did it the very first time, we would have wrote students in here. So the gender goes down here because those are the groups that we want to have it. And so basically when we draw these bar graphs, we are going to actually make them connect with each other. Okay? I know it sounds weird because in another bar graph you didn't have them connect. And that's another reason why I say I'm not a big fan. So, for the males, all right, we have, let's draw a little key here, okay? I'm going to use a blank square for the first response, which is glasses. I'm going to use lines to represent contacts. And I will blacken the entire thing out. You can use dots as well for neither. All right. So for the males, what percent wore glasses? For the males, what percent wore glasses? For the male, sorry. And this 1, 2, 3, 4, 5. What is the highest percentage of all my choices here? What is the highest percentage of all of them?
50%.
Close for all of them, for males and females. 57%, which means that I need to go to at least what?
60.
Yeah. I need to go to at least 57, which means I'll go to 60% in this problem. All right, so 50% were males. So I'm going to draw a bar for 50%. And I'm going to leave it blank because that represents glasses. Now, if you want to and you want to write glasses and put an arrow and say that bar is for glasses, that's good. And then for contacts, there was neither, right? There was 0%. So I'm actually not going to draw anything. It's actually a blank line. So there's this gap that's going to be right here represents nobody responded for contacts. And finally, we had 50% neither. Okay? Now, let's do the same thing for females. For glasses, what percent wore glasses for the females?
That's 50%.
57%.
57%.
So it goes a little bit higher up to here. Yeah, it's about right the same. 57%. And what percent were contacts?
Seven.
About 7%. And I sometimes, if you want to, you can write 50%, 50%, 57%, 7%. And what percent were neither? 37% were neither. So this right here, 36? 36. 36. Thank you very much. This is a side-by-side bar graph. It's not my favorite. I don't like it. To tell you the truth. But it's correct. What we're going to do is a segmented bar graph now. So we're going to do a segmented bar graph, which really just means that all we're going to do is we're going to stack the bars for comparisons on each other. And now there's something important here, because when you do this, they always sum to what percent? So if I take the left stack and I put them on top of each other, they add up to what? If I take the right stack and I put them on top of each other, they add up to what? If I put these on top of each other, what do they add up to? Good. If I take these, what do they add up to? 100. Yeah. So that's the nice thing about these as well. That's also I said why going to 100%. So that means that my y-axis, this is the beautiful thing about this, my y-axis always goes to what?
100.
Yeah. So 10%, 20%, 30%, 40%, 50%. And if you wrote percentages and then you wrote the 50s, you just got to make sure that you're noting that these are percentages: 60%, 70%, 80%, 90%, and 100%. Always, it's always these. Males, females still. And we're still going to break down it exact same way. So which means that this key is still going to be there. The same. I'm going to use the same key. I want you to note that everything is exactly the same. If you have colors, I did it with the blank, the line dashes and darkening in. If you have different colors, that could also be used as well. Just like you did with any type of graph when you had to do what a key is, they're called. All right. We're just going to stack them. Now, you got to be careful here. So remember, the stacks are what we refer to as cumulative. All right, that's a very big word, cumulative, which means that they sum up. So in my first graph, it goes to what? For glasses, what percent for males wear glasses? 50%. All right. The next stack was 0. So do I have to add anything for 0%? Can I, if I put 0% on it, there's nowhere to go, right? I'm still at 50%. Now I'm going to stack the last one, which is another 50%. What does it go up to?
Payment? It's up to the.
It goes up to 100%. Because this is 50% and this is 50%, which means they add up to 100%. You have to. The number one thing about segmented bar graphs is that the top better go up to 100%, and making sure that each section is. The biggest mistake I get students to do is that they'll say like one is 50% and the other one's like 57%. And so what they'll do is they'll make it so that like the next line stops at 57%, or like 30% and 57%. And they'll stop it at 57, but you have to add it, as you'll see in this next example. What percent wear glasses for females? What percent wear glasses for females? 57, so just a slight little bit higher. What percent wore contacts?
7.
7. Okay, so where do I go up to then? Where am I going to go up to?
Up to the 60. What is that? That 57? Up to the 57?
No. Close.
Close.
It's actually going to be around 64%.
64%.
Because you're stacking them. And this is the toughest part that I said. This is 57%. And this is 7. So cumulative means you add them. So that means the next bar will stop at 64% because you're stacking 57% with 7%. That's the hardest thing about doing these. And here's the beautiful thing. Where does the next bar go up to? There's only one other choice. So where does it have to go up to?
It's 100.
Always. Boom. There's only 3 choices. The last one has to go up to, and that's 36%.
It's 100 in total.
And that's 100 in total. Correct. I'm going to adjust the homework. I'm actually going to take off a problem on the homework I want to talk about. It's a very short type of topic. I want to make sure that A, you can write these sentences to compare, and B, that you can draw the graphs. So I'm going to edit the homework to get rid of, I have to get rid of a problem called association and no association. I could finish it within 3 minutes, but I think I want to take the time to let you process what we've done, and I'll cover that tomorrow. Remember, these notes that I've written right here are always located on Google Classroom inside the current days, like today's, when you saw those homeworks are in today's notes. I update them typically by the end of the school day, sometimes earlier. And I also put these lecture notes and this lecture video, same on the Google Classroom on today, as well as in the weekly organizer. So you can locate today's notes if you're ever absent, or if you ever need to look them over again. If you need to rewatch the video and hear me explain it, or if you just want to have the notes to be able to look at, Google Classroom, weekly organizer, or today's date. I'll update the homework. So there is a homework number 4. I'm just going to put C Google Classroom because I need to update and look at those problems so I can get rid of some of them. I think I might just have to get rid of 1 or 2. One like part. Okay? It's 10:48.